Hi guys, yeah, today's topic is the WS2812b LED. If you're not familiar with it, it's an RGB LED, which is a controllable signal of every LED because it is an integrated IC, and so you can individually control an LED in an array or on a ring like this here. And to test it, because I never had a hand on it, I really like this ring construction here, because it's could make nice patterns, running lights and for a clock or for gauge or whatever, or just for fun. And but of course there are different formats here. um, yeah, I admire this one here that has 24 LEDs, but they also have smaller rings with less LEDs. And of course, the price drops the less LEDs are on the board. But I will stick with this here, 24 LEDs. That's nice. And I have found this code here for the Arduino. For testing, I stick with the Arduino because that's a quick check. And you see here, it's from Lady Ada, and it's called the NeoPixel Strand Test.ino, and NeoPixel is just another word or name for the WS2812b. And let's see, include, see whether that's okay. Okay, there we have to define the pin we want to use, and I intend to use the Arduino Nano, and pin 10 should be fine. Parameter 1, number of pixels in strip, okay, Arduino pin number, pixel type flags add together as needed, neo kilohertz 800, bit stream, blah 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 blah. Okay, and okay, 800 kilohertz, that's the clock rate I want to go. And GRB, that's the order in which you have to shift in the colors. And so you have to configure that. Let's see, go to the Arduino ID. Okay, I set already, pin 10 is fine. Then we have to configure this here, seesaw NeoPixel strip. So 12 is not correct. I want to use 24 LEDs on this ring. And GRB is the correct order for the color information, and 800 kilohertz is already correct. Not sure if 115, 200 baud is fine, but I will stick with it for the first try. And the rest of the code should be fine as it is. But before I can start, I first have to make a possibility to connect the ring, and I will use this connector for single inline socket, and I just need to cut it to length, and I will use this tool here to do this, because that should work quite fine to cut the plastic here. And I need 4 pins actually. Okay, there it is. Oh, the cut looks quite good. Yeah, as you see here, it's a nice finish. And yeah, I have my 4 pins here. And yeah, the other part will be saved, of course, for the next project. So here's the LED ring with its LEDs, and yeah, that's where the connector needs to mount it to. First let's cut it open here. Ta-da! And there's the ring as it actually looks. Yeah, looks quite good. Production quality seems to be quite fine. And yeah, there's the connector, or connector pads. Actually, there is no connector. Come on, focus. Yeah, that looks better. Yeah, and you see DI, 5V, GND, and DO. That's where I have to mount the connector to. And yeah, it has to be soldered like this. And I want the black part of the connector to be against the ring, so that I don't have to minimize force, and yeah, to solder it, I just put this thing under it, and as you can see now, the connector lays in parallel to the ring surface. Just align it, and then that looks good. So I can solder it. I will solder just 1 pin for the start, because as you see it misaligns, and after I have soldered this first pin, it is kind of fixed. Yeah, that's good. Look, just have to focus it again. Focus, focus, focus. Yeah, okay, yeah, as you see, that looks quite good. And the pins are quite good aligned to the pads. So I can solder the rest of the pins. And the gold-plated pins are quite nice to solder. No oxide layer is preventing a good soldering. So that's the end result. I'm satisfied. As you see, the alignment is quite good. It's parallel to the ring. It's a nice result. I'm satisfied. And now I can proceed. Okay, I connected the Arduino Nano, but it still says here not connected. That's not true. Let's see if I already can upload it. Okay, it's compiling the sketch. Upload error. Okay, why is that? Let's see. Board Arduino Nano. That's fine. Port. Well, should be then COM5. Okay, now he's got the Arduino Nano on COM5. That's fine. Let's see if I can upload it. Compiling. Uploading. Okay, done. Okay, so now I can connect the LED ring, and yeah, to give you a glimpse of how the connections will be made as I intended it. Yeah, you see here on the right side, that's the connector to the LED ring, which I have soldered beforehand. And on pin 1, that's DI, that's the data input. And the code recommended to put a series resistor inside that data line to prevent damage between, I think it was 300 and 470. And yeah, I just pick 453 ohms, that's fine. And the code said already that you should place a capacitor of 1000 microfarads. Let's add that. 1000 microfarads, and it should have a proper voltage capacity, that is at least 5 volts. So better 10 volts or so. Okay, there you have it. And yeah, it should be placed directly at the 5 volt input and the ground. And also this line here should be as short as possible, because 800 kilohertz is a pretty high frequency and you cannot run it over a really long line. And then I have to connect here the 5 volt DC 2 amps power supply with 5 volts and the GND, and here the DI goes directly to the Arduino Nano data pin 10. And of course also the Arduino GND needs to be connected. So I will do that, and I hope it will run and give some nice lighting effects. Okay, here's the Arduino Nano. And first I want to check what's actually the voltage on the board. If it's 5 volt, 5.2, 4.8, whatever, I need to know. And that's the pins here, GND and 5 volts. And it's 4.77. Okay, 4.77, because that's important, because when I add the external power supply, I want to have roughly the same voltage, because it should not differ more than 0.7 volts or so. Okay, then let's see. And as a power supply, I want to use this LM2596. Switch down or back. Power supply. And I have to connect 12 volts here. GND first. Okay, then let's measure the voltage here. Oh, 0? That's not good. Shouldn't be 0. Let's try again. No, it's 0. Why? Do we have an input here? Not really. Okay. Check that. It's off camera. Connections to the 12-volt power supply. Let's see. Do we now have some juice? Okay, the LED is already on. That's a good sign. 5.24. Oh, okay, that's too much. I want to go to 4.77, but luckily I can adjust the output voltage here easily with this variable resistor here. So that's where I can change the output voltage. Let's zoom out again so that you can see the voltmeter. I just need some connections here because I have no 3 hands here. Okay, here we are in business again. And in this way I can connect the multimeter here to ground output and to the plus output. And I have my hands free. You see, it's still 5.2 volts. And I want to go to 4.77. Oh, well, that was fast. 6.5, 6.7, 6.7, 6.8, 9. Oh, it's not easy to adjust it. Yeah, okay, that's pretty close. 4.77 or 4.78 to 4.77. I think that's good enough. It's just 10 millivolts difference. Okay. Okay, then let's make the connections here. Let's see. I have this capacitor here, and instead of a 1000 microfarads, I use a 2700 microfarad capacitor because I simply haven't a 1000 microfarads, but more capacity should be even better there. And it has a rating of 16 volts, so it has enough headroom to 5 volts, so it doesn't make bang. Okay, let's see. I just need to cut that the pins have the same length, because otherwise it's always tilted here on the breadboard. Let's see. There's one end. And now they have the perfect length, both of them. And yeah, I will just ground this up here, the blue line. Connect it here. Of course, a breadboard is not ideal in this situation, but yeah, for testing it must be sufficient. And now I have to connect somehow these cables here. Let's see here. I'll use this cocoa clips here and connect it this way. yeah, I just put this connector here, this improvised connector, up here. And this way I can connect it here. Okay, plus to plus, minus to minus. Then we have the LED ring. With its connections, and yeah, let's connect that. And yeah, 5 volts needs to go to 5 volts. I use the red one, and data input is yellow and GND is black, of course. And the out, yeah, I don't use it because there's no other ring currently. And yeah, then let's see. I place the resistor. You see it? Okay, it doesn't want to focus it. Okay, too small. Let's see. Push it one side and the other as well. Okay, it's in. And yeah, it's pin 10 where we start. Let's see. Pin 10 is... where is it? It's there. Okay, to the start of the resistor. And yeah, I don't want to connect it under power, so I disconnect the power source already, because as you might remember in the code, there was stated that if you connect it under live voltage, connect ground first. And yeah, to do it in a correct manner, I will do that, even if I don't connect it under live voltage. Okay, ground to ground, plus to plus, and yeah, the data pin to the other side of the resistor here. Let's check if these are still inserted here correctly. Yeah, it looks just a bit odd because they are sticking out. Yeah, okay. I just have to connect the capacitor. No, it's connected to the power rail here. It should be fine. I just could change that and go closer to where the ring is connected to have just short connections. Okay, I think then we have the data pin via the resistor, and then it goes to the data input line. The 5 volts goes to the 5 volt rail, and the GND goes to the GND here. And yeah, I just have to still connect the ground of the Arduino Nano to the ground rail. Okay, so the
ground of the Arduino is the second pin, and it needs to connect it to the ground rail. Go in there. Oh, it's a bit sloppy here, but it should be fine. Okay then. So now let's check or recheck all the connections. The data line goes from pin 10 to the resistor, from the resistor to the data input line. The 5-volt connection goes to the 5-volt rail here, and the ground goes to the ground rail here. We have the capacitor in parallel to the power rail, and we have the ground of the Arduino Nano connected to the ground rail. So all voltages are based on the same ground now. And if I now connect it, you see nothing happens. Let's check. Maybe the data pin is not correctly connected. But no, it is pin 10. Well, let's measure if the voltage is present on the ring. Let's see, there's 5 volts. There's GND. Yes, we have 4.77 volts. That's fine. And that's the data input here. No.
Okay, I checked all connections and all connections seem to be right, but yeah, as you have seen, the ring doesn't light up at all. So yeah, in my experience, sometimes the example code you try is wrong in some way, and for whatever reason, it just doesn't work. And yeah, so I will try another example code, because that's the easiest way to test it. I need to know if the part is okay and working or not. And yeah, I found this site here, ArduinoGetStarted.com, and they also have a tutorial or an example for the WS2812b LED. It's for a strip, but who cares if it's a ring or a strip? And it's for Arduino. And yeah, the capacitor and the resistor and stuff like that, it's already mounted, as you have seen. And yeah, okay, we know that we have the GND, VCC and data in pin. And okay, they use pin 2 and a 470 ohm resistor. Yeah, so that's all fine. And yeah, okay, declares an object, initializes the LEDs with begin, and set color of each individual LED called pixel. Okay, and set brightness of all strip. Okay, so that's the functions which are provided here. And okay, there's the example code, and it turns pixels to green one by one with a delay between each pixel, turns off all LEDs for 2 seconds, then turns on all pixels to red at the same time for 2 seconds, and then he repeats that in a loop. Okay. Let's see. Whoa. Okay, Is that all? Yeah, the slider is at the bottom. Let's copy that. Let's make a new sketch. Okay, that can be deleted. There we have it, and let's see here. It includes the Adafruit NeoPixel header file, and that's important that this is installed, and I know it's already installed on my Arduino IDE, so if you haven't, you need to do that. And that's done via the Manage Libraries menu entry here. When you then search for the Adafruit NeoPixel.h, then you will find it, and define the pin. And yeah, we use the pin 10 as before, and define num of pixels as a number of pixels. Yeah, we have still 24 LEDs here. Yeah, the rest is just fine. Okie dokie, so I can verify it, so it compiles. Yes, that's fine. And yeah, I will flash that into the Arduino Nano, and then let's test that.
Okay, here it is, and the new code is flashed to the Arduino Nano. So let's see, I already powered it. Now I need to connect the LED power line. Minus to minus, plus to plus. Oh, it flashes up. Yeah! Haha! How nice! Yeah, that's the green part, and that's the red part. On camera, you can see it pretty good. Maybe if I switch off the light. Okay, green is of course oversaturated then. Red as well. But yeah, anyways, that works as intended. How nice. So the ring does work. And it's amazing how bright it is. I haven't checked if the code sets the highest intensity, but that's already pretty bright here. You can use that for illumination purposes.
Okay, before I change the code, I want to take a look on the datasheet here. Let's see here, features, benefits, that's fine here. Every pixel of the 3 primary color can achieve 256 brightness display levels. It completed its a lot of colors, over 16 million colors when you mix it. And yeah, that's important here, that the data is sent, it has to be sent pretty quick with 800 kilobits per second, which is 800 kilohertz. So it's not possible to use an MCU with a low MCU clock or core clock. So you cannot use a 32 kilohertz core clock MCU and try to achieve 800 kilohertz output. So the core clock has to be at least 2 times or 4 times higher than this rate here. Okay, anyways, that's how they look in detail here. It's really fascinating that they were able to integrate a little IC into the LED housing, so that the individual LED control is possible. And you see here the power supply voltage has to be within 3.5 to 5.3 volts. So it's important not to exceed that value here. And yeah, you also see that it's not possible to power it with 3.3 volts because 3.5 volts is needed. Let's see, there we have the parameter, the parameter of course, the input current, and that's 1 microamps, but of course that's not the real input current, but it's the off current or input current in the off state when all LEDs are deactivated. That's pretty low, that's good. And the input voltage level for the digital signal has to be at least 0.7 volts of the supply voltage. So the high state of the data line needs to be at least 70% of the power supply, which is 5 volts, and 0.7 volts or 70% from 5 volts is more than 3.3 volts, so it's not possible to control the LEDs with the 3.3 volts microcontroller. So if you want to do that, you need to have a level shifter in between. And I missed the statement about the complete current for one LED, and I found it on the web. It's 52.5 milliamps when all 3 LEDs are activated on the highest intensity, I think. You need to verify that later on. There's the characteristic of the red, green and blue LED. And you see that the luminous intensity differs from between the individual colors. And green is the brightest, followed by red, and the lowest is blue. But the human eye has a different perception, so it should look different to the human user. That's what I have looked for. That's the composition of the 24 data bit that is shifted into the LEDs, or in each individual LED. And so first you shift in 8 bits. Well, the first 8 bits are for the green color. Then the next 8 bits are controlling the red color, and the last 8 bits are controlling the blue color. So I mean that's what is done under the hood by this header file, but that's how the data has to be sent into the LEDs. And here you see how they are connected in series. So the D out is connected to the next LED D in, and so on and so on. Okay, fine. So here we have the loop with that for loop. That's where all pixels are turned on, pixel by pixel, in the green color. And it should be easily possible to add 2 more for loops, and in the second for loop I set the first value to 255 and the others to 0, and on the third this goes to 0 and the third value goes to 255. That should give us all 3 colors. Let's see if that works. Okay, let's verify that, if that compiles without errors. Yes, that's fine. Then let's upload it. Okay, that's done. Let's test that.
Okay, let's see. Again, I have to connect the power supply for the LEDs. Okay, that looks promising, but that was just the turn on flash. Ah, look at that. First green, then red, and then blue. Yeah, that is nice. Then the 2-second pause, the red full turn on, and then it repeats itself. So yeah, now it is clear that the ring works with all individual pixels and with every individual color. That's nice. Also curious about the current consumption, the actual current consumption. Let's measure that. So let's disconnect the power here, and then I measure at the ground side here. And I switch to the higher current here range because 24 pixels draw some current. Yeah, as you see, the current doesn't change much with the color. Of course, the more pixels are on, the more current we have, but it's 300 milliamps for green, and for red is it nearly the same, and for blue, it's also roughly 300 milliamps. And if I calculate that, 300 divided by 24, we have 12.5 milliamps per LED. So obviously it's not the highest intensity setting, but that's more than sufficient right now, for me at least.
Okay, I have changed the code another time, and this time I just had the intention to display a pattern like a moving wheel, and as you see here I just daisy chained the for loops and just start on different positions and end on different positions. It's, as you see, it's always shifted by the value of 2. So it starts on 0 and stops on 1 and starts on 2 and stops on 3 and so on and so on. So that goes all the 24 pixels through. And yeah, then I inserted a delay of 500 milliseconds. That's when it's displayed basically, and then the same part starts over again, but just with a changed color pattern. So instead of having 255 here, 255 moved there. So we have red here and blue before. So that goes on until the 24th pixel. Again, 500 milliseconds delay. And then it starts over and over again because I inserted, where is it? Here it is, a while loop. So it starts over and over again. So let's see, does it compile? Yes, it does compile. Yeah, I will program it and then we can have a look on it.
Alright, it's programmed now, and let's see if the pattern works. First Arduino Nano to power, green light is on, and then power supply for the LEDs. Okay, that's the start phase here. Then yeah, that looks nice, like a moving wheel. At least that gives the illusion of some animation. I like that. Complementary colors, so that's really nice. And I have a second ring here, and for example, 2 rings could make the illusion of a moving bike or so. I don't know if I will do that, but I think it looks nice. I dim the light a bit so you can see the virtual LEDs a little bit better. I don't know if it's sharp. Yes, it is. It's just oversaturated. But you see, it looks like it's animated. I mean, it's depends on your vision. If you see that it's rotating right or left. But I really wonder how they did it to implement an IC in such a little housing. So let's have a look on it. Here it is in detail, and the black square you see there in the middle, that's the IC actually, and the fine wires which extend from it, that's the bond wires which make the contact to the IC. And if you count the fine lines, it's 7 of them. And that's I really understand why it's 7, because what does the IC need? It needs VCC, it needs GND for the supply, and DI for the data input. Then it has DOUT for the data output. That's already 4 wires, and then it needs R, G and B control to the corresponding LED, and that's 7 of them. So that's how they did it. And right next to the LED housing you see a capacitor, an SMD capacitor, and I think that's necessary to stabilize the VCC for the chip, because usually in general ICs don't like it when the VCC flickers or breaks down several millivolts or volts, and so it needs to be quite stable. And you may also wonder why I was so detailed about the voltage of the Arduino Nano and the power supply for the LEDs. And let's have a look on this little schematic here I made. You see that we have VCC,
DI and GND lines which go to the IC, and we have 2 diodes, and I assume that these 2 diodes are incorporated into the IC actually. And these diodes are for protecting the port, in this case the DI port, from reverse voltage and from over voltage. So imagine if the voltage on DI is higher than on VCC, then eventually the upper diode will start to conduct. And if it's a silicon diode, which it is, I'm pretty sure about it, then it is 0.65 volts higher than the VCC, then the diode conducts and actually makes a short circuit there. And for example, the Arduino Nano pin doesn't like it when the voltage, when the current goes over a certain value, and as it is not limited, the current can be quite high and destroy your Arduino Nano, Uno, or whatever microcontroller you use. So that is why it is a good idea and why it's recommended to put a resistor inside the DI line, which just basically limits the current, so it cannot exceed to dangerous levels. And also the recommended capacitor you see here is pretty important, because I mentioned it before, the IC or ICs in general doesn't like it when the voltage flickers, and so it stabilizes the voltage when these impulses of current are drawn from VCC, because also this upper line here between the IC and VCC pin represents certain resistance, and of course there will happen some voltage drop, and even the line from VCC to the power supply is as well a resistance basically, and some voltage will drop there when the current rises, and the capacitor stabilizes this and makes the IC feel comfy. Alright, I'm so happy that the LEDs are okay and work as intended, so maybe I can make a little project later on with it. If you're not already a valued subscriber, you can now become one. Just join the community. I really appreciate if you take a look on my links in the description, where I also list this LED ring, of course, and where I also listed the mentioned products and my tools, of course. So I wish you a great day, and I will see you next time. Bye bye.